Hey, what's going on, everybody? Lars here. Um, Time for the second of three review videos that we are going to do for Unit 3. Remember, Unit 3 is the big boy. It is the one where we go over modularity and compartmentalization. In the first section, we went over functions. In this section, we're going over file I/O. And in the last section, we're going to go over libraries and modularity and things like that. In keeping in our theme, I'm going to try to go quickly. But again, like I always say, I'm going to try to balance quick with useful because I want you to get as much out of these review videos as possible. I'm shooting this on Sunday, the 19th. You're probably going to get it later in the week, but I spent the morning as a judge at Hack Hers, which is a female-themed hackathon. And some of the projects that the ladies did were absolutely fantastic. There was a project where you had to learn a little JavaScript in order to do art. You had to use JavaScript to change like brush sizes and paint colors and stuff like that. That was really neat. There was a game that you had to play with any money that was left over in your budget. You would play this game, and if you did well, you got more spending money, and if you didn't do well, you had to put it in savings. I thought that was kind of cool. And there was even an app that tied your music list to the current weather. So if it was cloudy out, like it was this morning at the Cook Student Center, then you would get songs with the word cloud in it, or you would get, slow plodding songs. It was really, really cool. So a good time was had by all this morning in Hack Hers. So I'm going to do this video, and you're probably going to get it later in the week, and then I'm going to hopefully front load the third video and get you that so you have like, I don't know, maybe 10 days with all the resources to do your projects. Again, I digress. I want to get going. Today, we're going to talk about file I/O. And whenever I shoot this video, as I've done in the past with my previous classes, I always tell this story. When I was a student and I went to university for computer science, it was the 80s, and academia didn't really have a handle on how to teach computer science yet. Like we do now, they would teach intro, and you would learn a little bit about, theoretically your first computer language, although back in the day, most of us came already knowing quite a few languages. But they would teach you your first language, and along the way, they would teach you computer science concepts, searching and sorting, recursion, big O, the kind of things we're going to get in Unit 4, because I extract all that stuff while I'm teaching you how to program. And the second class would be data structures. It pretty much still is now. Teaches you ways to organize your data so, time-tested algorithms can work on it and you can get things done. And then after that, in the 80s, it was the wild, wild west. Okay, they didn't have a handle on how to teach discrete math yet. They would just shoot us over to the math department and tell us to take probability and statistics. They didn't have a handle on maybe we should do computer architecture, then principles of programming languages, and then somewhat up there. You had those classes back in the day. It was called Survey of Languages. And you had operating systems, and you had compilers, and you had some other things, but it was just wild, wild west. One thing that universities did back in the 80s was they threw a whole bunch of different languages at you. So when I was a student, I took COBOL, and I took PL1, which was C before there was C, and RPG, report generator, of course, Pascal, Fortran, all this different stuff. And as you took all of these language classes, after you took 3 or 4 of them, you realized, hey, there's only really 7 things I need to learn how to do when I learn a new programming language. And it's kind of the things that we're going over in this class. You have to learn how to deal with data. You have to learn how to deal with decision structures. You have to learn how to deal with arrays or lists. You have to learn how to deal with iteration. You had to learn to deal with functions and things like that. And there was always something that they skipped. And I never understood why. And it was file I/O. When I say I/O, I mean input, output. Whenever you go out into the real world to become a computer programmer, you without a doubt are going to be dealing with files. Nobody says go into a loop and generate the first 500 Fibonacci numbers, or create a list with the numbers 1 to 1000. It's not going to happen. You're going to be given a file. Now that could be an Excel spreadsheet, that could be a video, that could be whatever. You're going to be given a file and expected to bring it into your program so that you can analyze things and go over the numbers and crunch things and boom, boom, boom. It's very important. And I always wondered why it was left for us to figure out. So, as I always say, this little section is my message to the people who taught computer science in the 80s. File I/O is important. And I always said when I became a CS educator, I was going to include it. So I always do. So without further ado, let's look at some file I/O stuff. The first thing we're going to do is we're going to discuss what a file is. At the end of the day, what is a file? And the way I do that is I show you what a program is. What's a program? It's a saved list of our logic and list of our things that we keep on the hard drive. That way, if I shut things down and I go to bed or I take the garbage out or I walk the dog and then I come back, I can reload my program so I don't lose it all. It's in a file. Well, file I/O that we use with programming is that, but for your data. It's usually we keep our datas in files. So that way we could save all the data in a file, be it an Excel spreadsheet or a comma separated value. I'm sure you guys have seen and know about all this already. That way I can either read from it or write to it, save it, and the next day it's going to be there. I don't have to worry about it being read into RAM, or I don't have to worry about it being in a program or created when I create my program or things like that, okay? It's basically what we would call a durable store. It's a durable store on your hard drive or in the cloud or wherever you save it so that you can always access that data at a later time, okay? When we're talking about files, and basically we call them files because that's the way operating systems were set up and that's the way hierarchical directory systems with different files in them, like filing cabinets. That was what people were thinking in the 60s when they did operating systems and they decided they were going to have to categorize data in different ways. So that's what we got. We got the name file and we kind of got it kept in a hierarchical directory structure. Yeah, so that's pretty much the story with files. What we want to do as Python programmers, though, is if we have a file and it's got data in it, we want to learn how to access it. And then when we're done accessing it, close it so that, we're good file citizens, that we don't leave it open so nobody else can use it. So the way we do that, and I do it right here in these first 4 lines, is now I could just put this in here, but I don't. I create a variable called inFile, and I assign it the string small e22.txt. Now that is not coming out of whole cloth. That is a file that I have here in my directory. And as you can see, it is a comma separated value file with a whole bunch of names. We're going to find out how many names in a little bit. So that directory is right there with the program. So because the program I'm running is in the same directory as the text file, we don't have to put any path information in there. We could just spell out the name, okay? Then what I want to do is I want to grab a variable. Here simply I just call it f. And I assign it the results of the open function, and open opens the file. I use the file name, in this case stored in a variable, small e22.txt. That is called small e22 because I believe this was the text file used in Euler problem number 22, only I chopped off a bunch of it, so it's the smaller version. I think we deal with the bigger version later, or you do in your slides, and I put it in your resource directory because of that. And then as you can see, I put an R there. That R is for reading. You can see it's surrounded by single quotes. Okay, so I do an open function in file, and then I make that equal to the variable f. Then what I do is I grab another variable called data, and I make it equal to f dot read. So if I have, basically f is now what's called an object. And I know I'm getting into the object-oriented stuff. And read is a method on that file object. So by saying f.read, open, close paren, I'm reading everything in that file, and I'm throwing it into the string data. Okay? And then I'm closing the file. So I say f.close. And closing is very important. I always say when I close that I'm being a good file citizen. Because back in the day, if you left it open, no one else could access it. And it would sit out and waste memory when you didn't close it. Now we don't care. We're lousy with memory. But back in the day, you cared, so you closed it. It's still a good idea to close your files, all right? So now I have a string called data with all of that information in there. And as you can see right here, first thing I'm going to do is I'm going to print data so that we can see it. So let's run this code. And woof, hello. Look at that. Okay, so we run all those names. As you can see, let me get the code next to the names so we can see some stuff. And I'm sure my big fat head is right there talking to you while all this is going on. I don't see my big fat head. That's something I stick in there later with Camtasia. So I don't know where my big fat head is. It could be here. It could be here. I don't know. So you can see I print the names, and all of the names that were in that file, okay, right here, are now in my string called data. All right. So what I do, just because I can, is I do a len on it. And when I do the len on it, you come down here and you can see 5128. Now, what does that mean? Does that mean that there's 5,128 names in there? No, because it's a string. Okay. So what that means is this entire massive string is 5,128 characters long. Okay, that's what that means right there. But we are going to fix this because now I have my data in. So that's great, but now I want to work with it. What do I have right now? I have a string, okay? So I don't want a string. I want something else, and I believe I have some code down here that's going to make our lives a little easier, okay? Let me close that off because I have some more down there. I'm going to clean the data. And how am I going to clean the data? I'm going to clean the data by handling a comma-separated value file and putting all of the individual entries into a list. And I do that in a two-step process. The first thing I do, and I'm going to show you after I do it, is, and I don't want to print len, I want to print data. Okay, so the first thing I do is data equals data.replace, and I replace the quotes with nothing. That's single quote, boom, boom. That is nothing. So basically what I'm doing is I'm getting rid of the double quotes. And you'll see if I run it, there you go. You just have the names separated by a comma right now. I got rid of the double quotes. And I saved it so that the change sticks. And now what do I want to do? Now I'm going to do a split. Now, two things here. One, we're going to split by the comma. So the comma is going to be our what's called a delimiter. The comma is going to tell us when to split, okay? And split is a method that runs on a string, but it returns a list. So after we do this operation, we're going to have a list, and the list is going to contain all the names, okay? So you'll see when I print it what we get. Watch. Boom. You see single quotes separated by a comma, but, and I'll show you the very top. See right there, that bracket? It's a list now, okay? You see down there? It's bracketed. It's a list. So now when I do a len on it, I get 579. Now I know there's 579 names. Because when I do a len on a list, I get how many items in my list. When I do a len on a string, I get how many characters in that string. Okay? So now I know I have 579 names. And you might be sitting there at home saying, yeah, big deal. You had a string and you printed it. Now you have a list and you printed it. Who cares? Who cares? No. We care because now we have it in a list. Now we have it in something we can iterate over. Now we have it in something we can examine and something that we can look at and do things. All right. Just with that simple clean, I got rid of all the quotes, and then I used comma as my delimiter, and I created a list. Now I can iterate over it. So of course we have code where we're going to go iterate over things. Let me go grab it. Look at that. Okay. So what I'm going to do here is I'm going to create a counter, 0. And for I in data, because now I have a list called data, I am going to run a counter. Now, if this is the first time you're seeing this, that might weird you out. That is the same as C equals C plus 1. Okay? That's running a counter right there. Just the plus equals makes it a counter. And then after I click my counter, I'm going to say if I, which is the name as we go through, equals Elva, then print the name and where it appeared in the list, because I'm just going to print the counter, and it'll tell me where it is. And then when I pop out, I'm going to print C, and that's going to tell me how many names I have total. I kind of know that already because I did the 579. It doesn't matter. All right, so we're going to look for Elva. You ready? Oh, boy, I hope this works. Yay, and we found Elva. So there's the 579 that we first printed. Do we want to keep that? Let's get rid of that for the time being and rerun it. Okay, so then we have Elva and 553. So Elva's pretty late in the game. I don't know if we can see, if we can eyeball Elva and find. I do not want to waste a lot of time doing this. It's probably obvious and it's sitting right there on the screen and I can't see it. There's Elsa. All right, forget it. I'm not doing it. And there's 579, and we knew it was 579 all along. But after we loop through all the data, that's what our counter is, which is good because it's what we got before, 579. Okay, so that's now we have something powerful. Now we have data that we read in from a file. We cleaned it. We put it in a format where we could iterate over it, and then we search for a name. Okay, that's doing something. Now, it took us a month, but now we're getting to something data sciencey. Okay, we searched for a particular name and we found it in our list. Okay, so that's the beginning of file input and output. Remember, this is very simple what we're doing. It's called dealing with sequential files. So it's like saving strings, one character after another, okay? Later, when you get more sophisticated in your programming, you're going to see there are binary objects, and you're going to read in things as objects, like Excel spreadsheets will be an object, and you'll be able to access the different cells and things along those lines. So that's all coming. Right now, we're doing just simple sequential file processing up and down the line, okay? But right here, we read in, 579 names, and we searched to see if the name Elva existed. It did, and we actually know where exactly in the list it is. So that is actually pretty cool. All right, there's two more things we are going to review before I get out of Dodge. And the first is that there is, I don't think I need that. There is another way in which we can access files. And that is with the with construct. As you can see, there's a quick one here. I have another file called numbers.dat. Let me go show it to you. Okay? It's not like the one that you ran in your slides. The one in your slides had a line of text up here. Here, my numbers.dat in this context only has the numbers. 12, 23, 34, 45, like that. Okay? You'll know why in a minute. So I just wanted to show you that. So what I do is I use what's called a with as construct. Okay? The only reason I'm showing this to you is because this is what Python programmers do, all right? I'm teaching you the basics with, open and then read and then close. But in most cases, when you have a file and you need to read that file sequentially, in Python, we'll read it line by line and we'll do it with a with as construct because of two things. One, you notice here I hard code the name of the file. I don't do the variable thing. It says with, and then I open it as F. So basically I'm saying with, and then open this file right here for reading as F, and then I use F, and then I say for line in F. So I basically iterate over it as I go, okay? What do you notice about that? First of all, I print it. Let me just do that. I run the code. Dun, 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 dun. All right, I probably did not. That's other code that we haven't seen yet. All right. Okay, as you can see, it prints out my file pretty much as it existed. See? How am I going to do this? How am I going to do this and this and this? See? Look at that. That's pretty swift. All right, so it pretty much matches. I read it and I printed it to the screen. All right? Don't want this. Get rid of that. Get rid of this. And basically, I did the same thing I did above with the read and the thing and the that. But notice what's missing here. Two things. You don't do a read. You don't have to. When you do the for and you iterate over it, it's like the read is implicit. So you read it line by line. And there's one more thing you don't see. You don't see the close. Because when that file runs out of data and you get to a thing called EOF or end of file, then the with as automatically closes it. So with as brings along your read, as long as you're iterating, which in a lot of cases you are, and it also closes the file for you, which makes it a nice little construct, which is why a lot of a lot of Python programmers, myself included, use it and use it a lot. Okay? So you saw we had numbers.dat. You saw we were able to read it in with just those three lines. And all I do is I print it out here and I make it an integer. You will see why in a moment. Because the last thing we're going to look at is output files. Okay? Do I want to? No, I don't, do I? All right, I want this to be the only code we're considering right now. So Now I want to create a file, but I'm not going to read from it. I'm going to write to it. And you're going to see with this little piece of code what we do. I create a variable called OF for output file. And I make it equal to, there's our open function again. I hard code the name, outnums.dat. I'm going to show you. Outnums, for goodness sakes, I didn't get ready. Outnums should not have existed. You didn't see that. Outnums does not exist right now in this directory. There's file stuff, that's a program. There's your small E22, but outnums does not exist. Numbers does. You still have numbers, the original file, okay? But outnums does not exist, all right? But out of whole cloth, I create the name outnums, and I open it with a W. And that says I'm going to write to this file, okay? You're going to see me do a write method, and when I do, I'm going to write to this file. So I use my with as construct, and I open up an input file. See, different name. Numbers is my input. Then I iterate for line in F. So for every line in numbers.dat, 12, 23, 34, 45, I'm going to go through this code block. So what do? I print it, just like I did before. But then I create a variable called bump. And what's bump? Bump equals an integer. I cast it. Line. So this 12 is going to be turned into an integer. And then I add 1 to it. Okay, so now I have 13. Bump is equal to 13. My first time through the loop. And then what do? I write it. I go OF, because that's my variable, dot write, which is the method on my file object. I turn it into a string, because when I'm writing to a sequential file, I want to write strings. Don't want to write numbers. I want to write strings. So what do? I write the string bump, so I write string 1, 3, and then I add a new line, so that it comes out nice like this. Okay? And you know the plus, when you're dealing with strings, is concatenation. It puts two strings together. All right? And then I go up and I grab the next one. For line in F, 23. Print int line, it'll print 23. Bump equals int line 23 plus 1, 24. So am I writing bump? Yes, I am. OF write bump. Okay? So there's going to be a new file called outnums.dat that's going to have 13, 24, 35, 46. Okay? So I'm going to run this code. Hey, and when I do, I get my original file, which I should have because I print it on my way. So I'm in pretty good shape. Now, output file, outnums. Nice. Let's go look for it. Outnums is there. Look at that. Pretty cool. We created a whole new file, but there's a problem. Do. It's empty. Okay. Why is it empty? Because we didn't do something very important. And hold on, I'm going to delete this. Boop. Come on. Ah, it is. I think I did this in a previous video too. I can't get rid of it. You know why? Because it is being used. Why is it being used? Because I never closed it. Look at that. Okay. When you are dealing with input files, you read the data into your string, and then you're good to go. You're ready to rock and roll. It doesn't really matter if you close the file or not. It's going to use up some memory. But like I always say, these days we're lousy with memory, so that's not that much of a problem. If some other people want to use it, they might not be able to use it because the file's in use. So you want to be a good file citizen and close your files when you're done. But with an output file, you have to do it because there's a little inside baseball going on here. When you run a Python program, either on another machine or on your laptop or something like this, you're not writing to the hard drive right away. What you're doing is you're writing to a little piece of RAM called a buffer. And that's where you're doing your writing when you write a file, okay? When you close the output file, that's when it gets written to the hard drive, okay? So you set up that outnums.dat for writing, and that's why the operating system had it sitting there, but it was 0 kilobytes. We wrote to the buffer, okay? But we never closed the file. So because we never closed the file, everything in that buffer never got written down to the hard drive, okay? Now we're going to do the close, and you're going to see, I think we're going to have a different result. All right, here, 12, 23, it wrote it this time, and it did the bump, and it iterated through for every line. It added 1 and wrote it to my output file, outnums, but this time I closed. Uh-oh, this time I closed. Outnums, look at that, 1 kilobyte. Might not be that impressive, but look at what we got. So As you can see, outnums.dat, every item is 1 greater than the one in numbers.dat. So this time it worked because this time we closed it. Okay? That's how you do an output file. You definitely have to remember to close when you're dealing with output files, because you have to take the results of that buffer and write it down to the hard drive. Okay? All right. You know me. I am going to take these files. Well, numbers.dat. Actually, do you already have the other numbers.dat in there? I don't want to give you a funny file name. And small e22, which I think is already there, and file stuff, and I'm going to put them in your Sakai Resources so that you have something to do. Let me go up here and get rid of this stuff. Does this particular program lend itself to a grand finale? It does. I was able to run the whole thing. Okay. I'll put this on the web, and you'll have it. Announcements. Keep chugging along. I'm guessing I'm going to get you this video at the end of the week of the 20th. So your assignments are right around the corner. I'll probably drop them on you this weekend. That way you'll have 2 weeks to look at them, because you're going to have to do the one little function, and then you're going to have to do read in random numbers from a file, consider those numbers with 2 different functions, but those 2 different functions have to be in a library. You're going to learn all about that in a couple of days, because I'm guessing Friday night or Saturday night is when I'm going to get around to doing the 3rd review video, and then I'll drop that on you as soon as I can. So you will then have your Zell readings. You will then have your slides. You will then have your 3 review videos for this particular unit. Other than that, be wary of the calendar, because you're going to be running out of time to do your midterm project. I mean, I'm looking at the clock right now, and it's February 19th, and I don't think your project is due until March 12th. So right now you still have a lot of time, but be aware, because it'll catch up on you. And I don't want you to have to spend a weekend doing 2 hours of Code Academy, then 2 hours of MIT OpenCourseWare, then 2 hours of Learn Python Hard Way. Do one a week. Keep good notes, okay? You do page and notes for each of those 2-hour sessions, and that paper's going to write itself. Then you think, oh, I like this because of this, and I like this because of this, and this might work because of this. And 2.5 pages, the magic of double spacing makes that 5 pages, and you've got a midterm. All right? So don't let that project creep up on you. Keep doing what you're doing. Engage with the resources. Watch these review videos. Tinker. Try things. Play around with the code I give you. And then when you get the assignment, you're going to have fun, and you're going to be able to put it together. And I'm guessing when you're done with this assignment, you're going to get that buzz. You're going to get that programmer buzz. You're going to be like, yeah, I did something, and I did something real. Okay? So I'm going to let you go for now. But video 3 is going to be coming down the pike very, very soon. Okay? All right. Then I'll talk to you later. You have a good night. Bye.